How's it, grade 12? So we're still busy with geometric series, but now we're going to be dealing with infinite geometric series. Okay, so the sum to infinity of a geometric series can only be determined if this common ratio lies between -1 and 1. Now, grade 12s, please highlight this, all right? This is a very important condition. If this does not hold, you cannot take the sum to infinity, all right? Now, your formula for sum to infinity is this should not be an n, this should be an infinity sign. Okay, so the sum to infinity is equal to a over 1 minus r. And that is why I wanted you guys to write your normal sum formula to be 1 minus r at the bottom there, because it fits with the sum to infinity. Now, this formula is given on the formula sheet, so you don't need to know it off by heart, but please know this condition, all right? If this does not hold, you cannot take the sum to infinity. Right, let's have a look at the first example. Find the sum to infinity of this thing here. All right, so I'm just going to write it down here. Okay, so remember, with anything with the sigma, expand it, okay? So if I put 1 in there, I get 1 over 4 plus. If I put 2 in there, I get 1 over 16 plus. If I put 3 in there, I get 1 over 64 plus. So on, so on, so on. And this carries on and on and on. Right, the next thing we're going to do is we're going to find out our common ratio. So you take this term divided by this term. So 1 over 16 divided by 1 over 4 will give us 1 over 4. So we're multiplying by 1 over 4. 1 over 64 divided by 1 over 16, you're multiplying by 1 over 4. Now, remember to take the sum to infinity. Our common ratio must lie between -1 and 1. And you can see that our common ratio, a quarter, does lie between -1 and 1. So therefore, we can take the sum to infinity of this thing, okay? So our formula for sum to infinity is equal to a over 1 minus r. Substitute our values in. So a is 1 over 4 over 1 minus 1 over 4. And now we can work out the sum to infinity. Okay, I'm just going to do this on my calculator. And we get a sum to infinity of 1 over 3. Now, why does this work, grade 12s? It's because all you're doing each time is you're adding a smaller and smaller and smaller and smaller number each time. So what's going to happen with the series is it converges. It comes very close to some number. And in this case, it'll be 1 over 3. Now, anything that's bigger than 1, let's say, for example, 2, all right? And if we look at a geometric series like this, multiply by 2, we get 4, multiply by 2, we get 8, 16, and so on. If we had to add this up, all we're doing is we're adding a bigger and bigger and bigger number each time. So you can see that we're not really going to converge there. This thing is going to diverge. It's going to shoot off, okay? You can only take the sum to infinity when you're adding a smaller and smaller and smaller number, which is this condition right here. And that's why that is so important. Okay, let's have a look at the next example. Sorry, upside down there. Okay, so example 2. Convert the reoccurring decimal 2.717171 into a common fraction. Okay, so we want to do 2,717171, so on and so on, and we want to convert that into a fraction. So what I'm going to do is I'm going to split this thing up. So this is actually 2 plus 0,71 plus 0, so I've done the first 71, now I must do the second 71. So this is going to be 0,071 plus, and I can do the next one, 0,0 0.000071 plus, and that carries on indefinitely. Okay, so what I can see here is, well, this is not really part of the pattern, so I'll just have 2 plus something at the end. What I am interested in is these decimal places here. So this is actually 71 over 100 plus 71 over 10,000 plus 71 over 1 million plus, and so on and so on. Okay, so how did we get from this term to this term? We'll take this one divided by this one, and you can see all you're doing is you're multiplying by 1 over 100. Likewise for this, take this term divided by this one, and you can see that you are multiplying by 1 over 100. So you can see that 1 over 100 is definitely lying between -1 and 1, so we can take the sum to infinity. Okay, so sum to infinity is equal to a over 1 minus r. My a value is this 0.71 over 1 minus r value is 1 over 100, and you can calculate that on the calculator to be 71 over 99. All right, but now just remember that this was not our original thing. This was just part of it. So what I need to do is I still need to add that 2. So 2 plus 71 over 99. You can calculate what that is, and we get 264. It looks like. I just want to double check that. $269 over 99. Okay, and now we can even check. So there's that 269 over 99, and we get 2.717171, and it repeats. Okay, right, so example 3, I think. All right, example 3. Now guys, I have seen this type of question pop up in exams before. So just pay special attention to this. For which value of x will the following geometric series converge? Now you remember this, when they say converge, your condition for convergence is that your r must lie between -1 and 1. Okay, so what I'm going to do is I'm going to find out what is our r. So example 3, we've got 1 minus 2x plus 1 minus 2x squared plus 1 minus 2x cubed plus, and so on. Okay, so what I need to do is we need to find out what x value will this thing converge. First of all, I'm going to find our r value, and in order to find our r value, we take t2 divided by t1, or we could take t3 divided by t2. It'll give us the same answer. So t2 is 1 minus 2x squared, and our t1 is 1 minus 2x. Okay, so one of these will cancel with one of those, and we get our r value to be 1 minus 2x. Okay, now remember the condition for convergence is that r must lie between 1 and -1. We've got our r value. Our r is 1 minus 2x. I'm going to substitute it in here. That is still the condition for convergence because that is our r. And now what I can do is I can solve for x, and that will give me my x value that will make this thing converge. So I'm going to subtract 1. So if I subtract 1, I'm going to subtract 1 from this, and we get -2. Subtract 1 from that, and we get 0. Now what I'm going to do is I'm going to divide through by -2. So that divided by -2 gives us 1. Now remember, grade 12s, if you divide through by negative, your inequality flips. Okay, and then divide this by -2, we get 0, but that will flip. So in other words, our x must lie between 0 and 1 for this thing to converge. In other words, to take the sum to infinity. Okay. Right, grade 12s, I would like you to do exercise 1.9. numbers 1A, B, C, E, F, H, 2A, C, 3, 4, 5, 7, 8, and 10, 11 for me, please. Thank you.